Okay, so last chapter was going to be about ecosystems. Now we're going to get even bigger and talk about the biosphere, which is going to be the whole Earth, basically, talking about that. So when we talk about organisms and the biosphere, we definitely need to kind of divide up biotic versus abiotic factors. So as you know at this point, bio means life. And if you put a in front of it, like here in abiotic, that means no life, right? Not living. So the biotic factors are going to be living factors, and that's going to be things like their role in the environment, pollination or predator, herbivore, carnivore, so on and so on. Abiotic factors are going to be the non-living factors. And so these are all going to have an effect on an organism too. So temperature. The reason that temperature is going to be important is because it's going to, if it gets too cold, the cells can't live. If it gets too hot, the cells can't live. But also just little increases in temperature can affect metabolism, right? Metabolic rates are definitely going to change. Water. There's going to be a certain amount of water that every organism needs. Too much or too little can kill them, right? Salinity, there are going to be some organisms that have to have salt to survive, and there's going to be others that can't tolerate it. Then sunlight, obviously sunlight too much or too little can cause burns or can cause them to not get enough nutrients, like how we need sunlight to make vitamin D, those types of things, or yeah, to process vitamin D. So then the last thing is going to be rocks and soil. And there's lots of things about rocks and soil. How many rocks versus soil are going to make up the components of that area, the pH, the consistency, so all of that type of stuff. So when we look at ecosystems on the whole, there are going to be two major things that are going to affect the biome distribution. So remember, biomes are going to be things like the savanna, the desert, the rainforest. We're going to go over those in a second. But solar heat, so energy from the sun, and then global circulation in the form of wind and ocean currents. Those are going to be the main things that are going to shape the characteristics of different ecosystems. So the sun is obviously going to be a huge factor. A couple of ways that it actually affects circulation is, and actually this picture is great to show you this whole idea. So as you know, the Earth is curved, right? So when you have the sun coming at you, it's going to hit different parts of the Earth differently. Right on the equator, it's going to hit it dead on. But anywhere above or below the equator, it's going to actually come at a different angle, right? So that's going to affect the type of pigments that are present in the leaves that are going to do photosynthesis and so on and so on. So the other thing that we need to remember is that the Earth is not straight up and down. It's tilted on its axis, right? And so that tilt is super important because that's what gives us our different seasons, okay? So remember how long it takes for the Earth to go around the sun, and hopefully you remember that takes a year. Somebody said 24 hours, and I was like, no. So it takes a year. And so what's going to happen is there's going to be some times when the northern hemisphere is closer to the sun and other times where it's further away from the sun. So when it's super close to the sun, like here, that's where we're going to have summer. As it starts to move away from the sun, that's when we have fall. And then when it's really far away from the sun, that's when we have winter. And then when it starts to get closer is when we have spring. So that's definitely going to affect how the seasons are going to happen. The other thing is, as the sun is going to hit, it's going to cause evaporation to happen. And so the water is going to go up into the clouds. And then as it gets further away from the equator, it's going to cool down and it's going to come down as rain. This is why there's tons of those crazy tropical downpours right around the equator. Now, these little cells actually, if you look, happen all the way up and down the surface of the Earth. And then what's going to happen is that's actually going to give rise to the global wind patterns that are called the trade winds. So if you look, and just our basic wind patterns in general, if you look, you can definitely see that it does kind of follow that pattern. The other thing I want you to notice is how they are going kind of clockwise up above the equator and then counterclockwise below the equator. We're going to talk about that in a second, what causes that. Okay, so we talked about the air rising. The rotation that I was talking about is called the Coriolis effect. And so that was back here the fact that these are going clockwise above the equator and then counterclockwise below the equator. The reason that happens is because the Earth is rotating. So the Coriolis effect is definitely going to be apparent, not only in the wind patterns, but also in ocean current patterns as well. Okay. So the other thing that can affect climate is going to be mountains, and obviously we have those here, right? So if I was to get my little drawing, okay. So let's say that we have some mountains, right? So obviously there are going to be some climate differences as you travel up the mountain. So the one thing you want to remember, and I'm just going to be lazy and keep it blue, is that we have the sun, right? And what's going to happen is the further up the mountain we go, the closer to the sun we get. So the more UV exposure we get. You've probably experienced this if you've ever gone skiing and you're like, oh, well, I'm up on a mountain. How could I get burnt? And you get fried. That's because you're getting more exposure to the sun because you're closer to the sun. The other thing is going to be that, ironically, the higher up you go in elevation, the lower the temperature gets, right? So that's why in the summer, when it's really hot, we like to go up to the mountains because we can actually cool off. So it's kind of weird to think about the fact that you're cooling off, but you actually have a better chance of getting burnt, right? It's kind of weird. Now, the other thing that can happen is what's called a rain shadow. And I'm actually going to erase our sunshine here, and we're actually going to change it to a cloud. Okay, so what's going to happen is clouds are going to have moisture in them. And they are going to release that moisture when they get cool enough, right? So what's going to happen with mountains is if these clouds are traveling in this direction, they're going to kind of reach a point where they're going to go a little bit up in elevation. And when that happens, that's where they are going to rain on this side of the mountain, right? So they're going to dump on the leeward side of the mountain, and windward side of the mountain. And when they get to the leeward side, there's actually going to be no clouds left. It's going to take them a while to build up until they're over here. So that's called a rain shadow. And that right there is why when we have snowstorms, you can kind of guess whether we're going to get a lot of snow or a little. Because what happens is, if we get a storm that comes down from the north, it's not going over any mountains, right? If it's coming from like Fort Collins area. And so we get tons of snow in Denver when that happens. And you can always tell when it's going to snow a lot because if I go outside, I can actually smell Greeley, which no offense to anyone from Greeley, but it kind of smells like cow poop. So if it's really cold and I can smell Greeley, I'm like, oh boy, we've got a big snowstorm coming. But if it comes from the west, where it's going to go over Vail and Keystone and Arapahoe Basin and all those big mountains, it's going to dump all the snow on those mountains, and then we're not going to get as much. But then the eastern plains get a ton of snow because it has time to build up again. So that's how rain shadows actually work. Now, in the next video, we're going to talk about different types of biomes.